This is Unit 2, Part 1, Significant Figures. In Unit 1, we learned that there is a difference between accuracy and precision. Whereas accuracy is getting close to the true or accepted value, precision is getting the same thing over and over again, even if it's not necessarily accurate. We're going to take many measurements in chemistry class, and all the tools that we use are going to have increments on them. And when we use those increments, we must estimate one more digit than we're given, and that's where the significant figures comes from. For example, in this particular demonstration, there's a line being measured between 2 and 3 centimeters. We can tell that it's clearly beyond 2.6, but less than 2.7. However, since we have these tenth of a centimeter, which would be a millimeter measurement, we can estimate the distance between here and here. So we'll add one more place to our number, which represents the hundredths place, whereas these individual lines would be the tenths. So looking at these lines, we would say it's more than 2.6, but less than 2.7, so maybe about 2.65, 2.66, depending upon how close you want to get. Either way, we're certain of the 2, and we're certain of the 6. We're estimating this hundredths place. However, they're all significant. Compare that to if we used a ruler that only had the centimeters labeled. And now we're trying to guess where this line is. Notice this gives the millimeters, or the tenths between the centimeters, and this gives nothing. There's no way that we could say that this is 2.65 without having the smaller increments in here. At best, we could say maybe 2.6 or maybe 2.7. Notice that we're leaving off this hundredths place because we can only estimate one more decimal place than we have, and right now we have 0 decimal places. This is where we get significant figures from. This is part of an activity that we'll do in class just to make sure that you can measure the distance of a line, which brings us to the rules for sig figs. When we use sig figs, you'll have certain calculations, and where you round those calculations is going to depend on how many sig figs you have in your measuring tools. So first off, most easy, anything that's not 0 is automatically significant. So the number 235 would have 3 sig figs. This number with a decimal, 2 places behind it, all of those are significant, all of them are non-zero. Very straightforward. Now when we get to zeros is where we have the difficulties. There are 3 types of zeros. The first one is called captive. As the name implied, they're in the middle of something. So in this case, you can see that this 0 here is in between the 2 and the 3, so it's considered captive. However, since it is captive, it's going to be counted as significant. That's a necessary placeholder between these 2 numbers. Likewise here, 30.7002. This 0 is captive, as well as these. All of those are significant because they're in between other non-zero numbers. They're non-zero numbers on both sides. The next type of 0 is called leading. These are not significant, however, because they're simply at the beginning of the number. 0's here and 0's here. Notice that they start the number. They're all the way on the left. No other non-zero number before them. These are not significant. These are placeholders that can be distinguished in another way, which I'll show in a minute. So for this number, we're going to ignore the zeros. Say that the 2 and the 5 are both significant, so this has 2 sig figs. Here we have 4 non-zero numbers, so we'd have 4 sig figs, since these are leading as well as these. Now the opposite of leading zeros are trailing zeros. Whereas leading zeros are never significant, trailing zeros are sometimes significant. For instance, 235.0. There's a reason that 0.0 is there, and since it is trailing to the right of a decimal, to the right of the non-zeros, this 0 will be significant. 235.0 is not the same as 235. Notice there's more accuracy here. That is not the same. However, when we get to this number, 2,350, notice that this is a trailing 0, but there is no decimal. When there's no decimal, this trailing 0 cannot be significant, so we would only have the first 3. But now when we add a 0.0 to that 2350, now everything becomes significant. As soon as you put this behind a decimal, that becomes significant. And then once this is significant, this becomes a captive 0. So essentially any number that's greater than 1 and has a decimal, everything automatically has to be significant. This number here, now we have two types of zeros. These, even though they're to the right of the decimal, are not trailing zeros. These are at the front of the number, therefore they're leading, and leading zeros are never significant. We will ignore those. Likewise with these, leading zeros are never significant. Even though they're to the right of the decimal, there is nothing non-zero up here. So for this, we'd have to count the 9, the 8, the 3, and then this is a trailing 0 to the right of a decimal. Trailing 0 to the right of the decimal is significant, so we count all of those. And here, trailing zeros to the right of the decimal, all of those are significant. Now sometimes when we have a number without a decimal, where we do want to show that a trailing 0 without a decimal is significant, we can use a bar over it. So for this first one, we have 330,000, just plain number, has 2 sig figs, both of the 3's. Now if we wanted to say that this 0 is significant, we can't just put a decimal here, because then that would make everything significant. So we need some other way. Way to do that is to put a line over it. So we would count this 0 as significant, so we have 1, 2, 3, and then these are still trailing zeros without a decimal. Those go away. If we wanted to show that this 0 is significant, we put the line over that, making this significant, automatically makes this a captive 0, which is also significant. So all 4 of these would be significant, hence the 4 sig figs, but these would not be. Now, instead of showing a bar, there's a better way to write numbers that are large like this and show that many sig figs, and that's called scientific notation, which we'll talk about later in this unit. Basically, in scientific notation, you're going to have a number that's between 1 and 10, that's called the coefficient, and then all of those zeros get put into a power of 10. So this 3 times 10 to the 4th would actually look like 30000. 30,000, you can see that it has 1 sig fig, just like this does. For scientific notation, we look only at the coefficient. These are just zeros, either trailing or leading, and we could ignore them. So in looking at this number, 2.8, we only look at the coefficient here. It has 2 sig figs. Now 2.80, since this is trailing to the right of the decimal and is clearly more accurate than just 2.8 by itself, we have 3. So 2.800 has an additional trailing 0 to the right of the decimal, so that becomes 4 sig figs. Moving on to the practice problems, which you should do along with me. 3 non-zeros, those are all automatically 3 sig figs. When you see a number that has something that is 0, you have to ask yourself which type. This is trailing with no decimal. Trailing with no decimal is not significant. It's just a placeholder. We could rewrite it in scientific notation if we wanted to. So this only has 3 sig figs. These zeros are leading. They're at the front of the number. There's no non-zero number up here to make them captive or trailing. So none of those is significant, and we only have 1 sig fig. Here, you've got 2 types of zeros. These are all captive because they're in between 2 non-zeros, so those are significant. This is trailing, no decimal, not significant. So we have 1, 2, 3, 4, 5, 6 sig figs. And finally, all 3 types of zeros in one problem. This is leading because it's at the beginning, so that's just a placeholder. This is captive because it's in between the 6 and the 4, so this is significant. And this is trailing to the right of a decimal, so that's significant. So we have 1, 2, 3, 4, 5 sig figs. If you need any clarification on that, please ask in class. And we'll move on to 5 more practice problems. Here we have a number in scientific notation, so we look only at the coefficient. This has 2 sig figs. These are trailing, no decimal, 2 sig figs. All of these zeros are leading. You might say, but these are to the right of the decimal, but in order to be trailing, there has to be something non-zero up here, but there's not. All of these are just leading, so they're placeholders. This is captive, so it is significant, so we have 1, 2, 3 sig figs. This zero is captive. These zeros are trailing, no decimal, so these are not significant. This one is 3 sig figs. And finally, leading, not significant, trailing to the right of the decimal, 3 sig figs. Now that you know how to count the number of sig figs, how you use them is in rounding. So in this case, I want to round each of these numbers so that it has 3 sig figs at the end. So what you do is you count over to however many you want, and that's where you round. So for A, we'll count 1, 2, 3. This is the spot we want to round. In order to round this following the appropriate rules, it would go up based on this 9. So this equals 42.7. Here, 1, 2, 3. We round this digit based on this 7. This one will round up, so this equals 1.68. Here, these zeros are not significant, so we cannot start counting those. You can't start counting sig figs until you get to the first significant one, which would be this 3. All of these are leading, so you ignore them. So for this one, we have 0.0038. Now we're going to round 1 to this spot. Looking at the 4, we're going to round down. So we just leave this as it is, so 0.00385. Be careful with this one. We're going to go 1, 2, 3. We want to round this number. So that equals 4, 2, this is going to round up, 428. Now, many of you are going to want to leave that as 428. However, you still have these placeholders that you need to consider. So if you made $427,835 a year, and your boss told you that he was just going to round that up and only give you $428, you probably wouldn't be too happy. That's because you're leaving off this hundredths, tens, and ones place. So in order to maintain the integrity of the number while still keeping it at 3 sig figs, we just put our 0 placeholders. That's why these are not significant. They're simply placeholders. Likewise with the next one. We're going to count 1, 2, 3. We want to round that 9. So this equals 8, 4, 9. Looking at the 3, we're going to keep the 9 as is, but you can't make this 849 for the same reason you couldn't make this 428. So whatever we're going to get rid of, we have to keep the place of, so we're going to keep them as zeros. And our last number, we move 1, 2, 3. We want around this spot. It's going to stay as a 9 because of this 3, so this equals 95,000,009, and make all the others 0. 0, 0, 0. So notice we rounded it to 3 sig figs. All of those are placeholders. And that concludes determining what is a sig fig and rounding appropriately. Later on we will move on to arithmetic with sig figs.